So the last page on page 14, this is an example where we're going to be using our calculator, and again, they're giving us the picture, and they're going to ask us to calculate the different volumes, and they're giving us different axes of revolution. So first of all, they want us to calculate region 1. So I'm just going to kind of redraw this. Here's region 1. That's 1. Here's region 1. And you're using an axis of revolution about x equals 0. So again, this is going to be a dy problem. And notice there is no gap, there is no break between your axis of revolution and the region you're rotating. So this is going to be a disk. So you don't have to worry about finding the outer radius minus the inner radius. So again, the equation of this line right here, they're giving you as y is equal to x. So then again, remember the area of my circles I know are pi r squared. So r is going to be equal to y. So then to calculate the volume is going to be the pi going from 0. Again, these lines are intersecting from 0 to 1 of y squared dy. So again, when I integrate this, I'm going to have pi times y cubed over 3. So my answer is going to be pi over 3. So now region 2 is this region, and again notice I'm rotating it about the line y is equal to 0. So region 2, here's my line y is equal to x, and then I have the equation y is equal to x squared. So I want to calculate the volume. Now notice I'm rotating it about y equals 0, so this is going to be a dx problem. Again, my point of intersection is 1, 1. So I do have to calculate the outer radius minus the inner radius. So the outer radius is my line y equals x. My inner radius to the axis of revolution is going to be x squared. So to calculate the volume is going to be equal to pi. Again, I'm going from 0 to 1. Outer radius is x squared minus x squared squared dx. So when I integrate, I have pi times x to the third over 3 minus, this is going to be x to the fourth, which is going to give me x to the fifth over 5. And again, I have to evaluate this from 0 to 1. So I have pi times 1/3 minus 1/5. So now notice they're giving me a different axis of revolution. They're asking me to rotate region 2 about the line y is equal to 1. So here's my region 2 again. So there's region 2. And again, they're intersecting right here. And my axis of revolution is y is equal to 1. Notice this is a horizontal line, axis of revolution, so I'm going to treat this just like a dx. But notice this is going to be a washer, because I have this gap between the region I'm rotating and your axis of revolution. So now again, the outer radius, you have to consider top minus bottom. So that's going to be 1 minus x squared. My inner radius is going to be 1 minus x. So to calculate the volume is going to be pi going from 0 to 1. Again, my outer radius is the 1 minus x squared squared minus the inner radius, which is 1 minus x squared dx. So be careful with your foiling. Again, when I FOIL this, is going to be 1 minus 2x squared plus x to the fourth minus, watch your signs here, when you FOIL this, that's going to give me a 1 minus 2x plus x squared dx. Now you may want to combine as many like terms as you can before you integrate. The 1 minus 1 cancels. Negative 2x squared minus 1x squared is a negative 3x squared. So the ones cancel, that takes it. I have an x to the fourth, and then I have a plus 2x. So now I can integrate. It's going to be pi. That's going to be negative 3x to the third over 3, which is going to give you a negative x to the third, plus x to the fifth over 5, plus 2x squared over 2, which is just going to be an x squared. And again, I'm going to evaluate this from 1 to 0. So it's going to be pi times negative 1 plus 1/5 plus 1. So there's for part C. A lot of times with these problems, they may just ask you to do your integral setup. And we're going to go over the last 3 in class together.